Hello everyone, and welcome to yet another Learn Live series at Microsoft Ignite. And during this session, we will talk about how to train and track your machine learning models with MLflow in Microsoft Fabric. And whenever you are, good morning, good afternoon, or if you're like me in France, good evening, because it's pretty late here. And I think it's pretty early for you, Kinfey, right?
Yeah. Hello, everyone. Good morning, good evening, good afternoon. This time, I will be with Chris to talk about machine learning topic in Microsoft Fabric. I think this session will very interesting and let you to learn more about how to use machine learning in Microsoft Fabric. Chris.
Yes, and we are not alone to introduce you to that topic. We also have two great moderators with us, Frederick and Konstantin, who are in the chat. It's a Learn Live session. It's live. Yes, I'm live at 1 a.m. from France to deliver that session. And Frederick and Konstantin are also live with us to answer any of your questions. So do not hesitate to hop on the Q&A section of Microsoft Teams and ask your questions right away. We will have a look at the Q&A and we might take few of these questions to answer them live as well. This is a Learn Live session, which means if you know the principle of this series, that everything we will show you today is based on a Microsoft Learn module. So you can go to that link and follow along and do the exercise even along with us. Or you can sit back and watch us doing all the work. This session will be also available in replay. And obviously, the Learn Live module is not coming away after the session. So you have the leisure to go through the exercise and learn by doing at your own pace, either during the session today or after the session. So what we will see today, Kinfey, can you introduce us to the objectives of today's session?
Yes, our session will give you three important topics. Our learning object, that the first thing is the train machine learning model with open source framework. Many open source framework to give you to choice to finish some more training model. This time we will introduce how to use this. Another is the very important thing is Microsoft Fabric. Microsoft Fabric has some notebook can let you to train your model to finish the step by step in your Microsoft Fabric's notebook to finish training model. The last thing is very professional things is the use ML or flows and experimental in Microsoft Fabric to let you to confirm the model good or not good.
Okay, so before getting started, just a reminder for people who have joined us just right now, but this is a live session and you have two moderators in the chat. Please say hi in the chat and ask any question you have. And I already saw one interesting question. I will touch a little bit on it. Is there a Fabric certification? Yes, we just announced the first Fabric certification, DP600. You can check out more on the Fabric blog. So let's start by an introduction. And right now, you're 100 people online following this session. So you may have a very diverse level about Microsoft Fabric and a very diverse level about machine learning. So whatever your prior knowledge before that session, we got you covered. So as an introduction, we will introduce what is the machine learning process in general. And I will also do a quick introduction about Microsoft Fabric. First, the data science process. So most of the time, data science starts with defining the problem. What do you want to solve? What do you want to predict? You can ask a lot of different questions, and we can do pretty amazing things with machine learning today. But you need to first ask what you want to do. Then you will need to get the appropriate data from either open source data sets or data sets from your own organization. That could be a little bit complex. Hopefully with Microsoft Fabric as a unified analytics platform, it will be easier tomorrow, but you might spend a bit of time on there. Then you need to prepare the data. Fact is, when you gather the data, it might not be with the highest standard of quality because people make mistakes, because it's converted from a system to another, from a database to another, or because it's just historical data and not all historical data have all the fields, for example. And in a data science process, you spend a fair amount of time in this step, in preparing the data. We have some tools in Microsoft Fabric to help you with that. We don't really cover them in this session, but I will just show you where they are so you can take a look if you're interested. And then you have the core of the data science process, what we want to achieve, which is training the model. If you have never trained any data model with any tools, we got very simple models we will use today, and with an open source data set, so you can replicate what we'll be doing today on your own environments. And once you have trained a model, or more especially when you have trained several models and you have determined which one is the best to answer to your problem, you will be able to generate predictions. Maybe, Kinfey, we need to introduce Microsoft Fabric for our attendees that do not know Microsoft Fabric yet, right?
Yes, Microsoft Fabric. I think Microsoft Fabric focused many areas. The first step is the real-time analyze and business intelligence and data scientists and data warehouse and OneLake and data integrations. This is the unique platform to let you to manage your data in the one platform. I love this style, but you can choose different roles, finish your data jobs. Just like if you are a data engineering, you can you can choose some data house or OneLake to finish some data analyze jobs. If you are a data scientist, I think you can use the OneLake data to finish your machine learning jobs. This session, we let you to focus some data scientists to finish machine learning with MLflows. Another is the data integration. I think data engineering always do this. Microsoft Fabric can give you more to do to finish this. This is the SaaS platform for you. I think today we announced GA for Microsoft Fabric. You can try to use this. Many customers to use Fabric to finish many data jobs. If you want to choose to trial, please listen our series live streaming. Yeah.
Yeah, and you're right. We just announced Fabric Reach GA, which means that you can use it in production, and we already have more than 20,000 customers using Microsoft Fabric since we announced Microsoft Fabric in public back in May at Microsoft Build. But before jumping into data science with MLflow, we just wanted to give you a picture of all the different places and all the different ways you can do machine learning with Microsoft Fabric, because there is a lot of ways to actually do it. For today's session, we will focus on notebooks and experiments and ML models, but you can also do anomaly detection, for example, in a real-time database, in a KQL database. We announced today that you will have access to OpenAI and Azure AI services right from Microsoft Fabric. And you have a code example here. As you can see, I don't have to put any API key. I don't have to put any link. I'm just calling the OpenAI framework and just starting to use GPT 3.5 here in the example. So very easy way to use OpenAI and Azure AI services. And obviously, Kinfey, you talk about data integration and data engineering. You can call Azure Machine Learning through that Azure through Synapse Data Factory pipeline in Microsoft Fabric. So let's jump to our first part of this 𝗏𝗲𝗀 series, and it's a bit of theory for now, but don't worry. Just after this section, we'll start doing some real work and some exercise. So first part is to understand how to train machine learning models. And the first thing you might know already if you've already doing some machine learning is, in terms of languages, you can do machine learning with a wide range of languages. Fact is, the prominent language we use in the machine learning world or the AI world is Python, and obviously Python is supported in Microsoft Fabric. And then there is a lot of different machine learning libraries that comes with pre-packaged machine learning algorithm you can use for different tasks. For example, you have scikit-learn, which is a well-known machine learning library for doing what I would call traditional machine learning, and this is what we will use in today's sessions. If you want to learn more about machine learning, if you're just a beginner, we have a free curriculum which is available on GitHub. You have the link here, and we will paste the link on the chat. For a more advanced scenario, if you want to interpret an image doing vision, or if you want to interpret languages, you will probably be doing deep learning models. For this, PyTorch and TensorFlow are two of the biggest libraries out there to do this kind of work. The image you have here is from one of my projects with the Surfrider Foundation. It's Plastic Origins. You have the link in the slides. And the objective of this project is to detect and count plastic litter in the river banks. And we do this with PyTorch and Azure. And if you want to learn how to build that kind of tools with Microsoft Fabric, we also have a great workshop, the Serengeti workshop, and you have the link there as well. But these different libraries, they are not made for a cloud world. And I think, Kinfey, one of your favorite things is Synapse ML, right?
Yes, Synapse ML. Today we announced GA2. This is very good framework for your ML Pi9. You can finish your machine learning and Pi9 to use Synapse ML. If you using OpenAI, I think Synapse ML can help you to finish some general AI projects, but this time traditional machine learning Synapse ML is very, very good skill for that. I love this framework. Yeah.
Okay, so before just going to the exercise, let's talk about how to train and track models with MLflow and what we call experience in Microsoft Fabric. So we put this little slide. Kinfey, do you want to walk us through the different steps here?
Yes. Let me to do. Yeah. The first thing, maybe if we want to train and track machine learning with MLflows, the first step is use notebook to open your notebook to gather your data. This is the traditional step. If you not use Microsoft Fabric, is you do the same things. You know. And the second step is MLflows step. You need to set the experiment name, just like you want to finish this training, you give this experiment. You can compare different experiments to find the good result for your model or a good result for training. You can set this experiment name. So you need to import MLflow library, and skip the experiment name and set the experiment name. The first step is to train your model. You can choose different algorithm for your machine learning, just like you can use decision tree and line regression to do this. But you just only call the class for decision tree or linear regression, not you define the algorithm. If you reduce to a step, you just only call the class. So just use the just like this diagram or picture is the decision tree regress in class and fit the X trait or Y trait. This is your trait data set here. And the fourth step, you need to compare runs, which is good or not good. You can find the runs and then to publish the best model. You can save as a model. Click the Save as Model button to finish this. The five step. Use the model. You can apply the model, use different version. You can choose which model you need to use to deploy or some tests or set in the back end and in the model. So you can click the apply this version to finish. If you found, I need to add some data or need to retrain again, you can repeat these 5 steps. I think it's very as easy to finish this. If your audience to our session, you can try to finish 1, 2, 3, 4, 5 steps. Follow this step to finish your first training or first model with MLflows in Microsoft Fabric. It's very easy. Yeah.
Yeah, and what we haven't say is MLflow is an open source project, so you can actually deploy MLflow on your own computer if you want, or in Azure Databricks or elsewhere. But with Microsoft Fabric, we've already deployed and scaled MLflow, so you have nothing to do. You just have to use MLflow. And where we use MLflow in these different steps, basically, if you were just training the model on your own, you would just have the 2-line, like create here on step 3, a decision tree regressor, and do the fit, call the fit method. The fit method is actually telling the framework scikit-learn to do the training part of the machine learning. And when you add MLflow on top of that, you create experiments so you can regroup all of different things. There is a thing that is called autolog that will automatically logs the input of your trainings and also the output, the model generated. So you can easily go from different training data sets or different parameters for your training and go back to all this history and compare results. And then MLflow is also the component that allows you to basically create your own library of ready-to-use ML models. And we will see at the end of the session that it's really easy to basically pick up a model you've published in MLflow and use it where you want. So without any further ado, let's go to the exercise. So I will switch to my computer. And if you have opened the link with the Learn module we shared with you in the chat, in the Q&A, you will end up with this Learn module. I will directly skip to the exercise part that I've opened here. For completing this exercise, whenever you are doing it live with us today at Microsoft Ignite, or if you are doing this on your own, watching the replay, you will need to get access to Microsoft Fabric. There is a free trial, so you should be able to get started quite easily. But sometimes, depending on your organization, you might end up in a situation where you're not able to enable Microsoft Fabric because your administrator haven't provided you that capability. If so, or if you're a student, for example, you can sign up for a trial of Microsoft Office and use that trial to get a Fabric trial and actually complete all these exercises. So what I will do now is I will jump to the Microsoft Fabric UI and I will split my screen. That's a neat feature of Edge. So I can have on the same screen, on the same browser, on the right, the exercise, and on the left, the UI. So here is the home page. If you don't know Microsoft Fabric, if you're just discovering Microsoft Fabric, here is the home page with the different experiences. So that's something that is quite cool because Microsoft Fabric is for any data profiles, from business analyst to data engineer. So what you can do is you can click on the Synapse Data Science because we are doing data science here. And by the way, you can switch easily between these different roles by clicking on the button you have on the bottom left of the screen. You see the selector again, so you can switch back between different profiles. So let's follow the instructions, try to read the manual. So we've navigated to the Microsoft Fabric homepage, that's done. We selected the Synapse Data Science, and now we need to create a new workspace. So if you're new to Microsoft Fabric, a workspace is basically like a Teams team or a folder into your OneDrive. Is an organizational unit, a place, a folder where you can put everything you need to work on a specific project, and where you can easily share that unit with your colleagues. To create a new workspace, you need to click here on the navigation menu on the left to Workspaces, and then you need to go to the bottom and click the blue button, green button, New Workspace. Creating a workspace, you just need a name. Let's say hello from Ignite. No description for now, nothing more. And I click on Apply to actually create the workspace. And because I will be working with Kinfey on this project, let's share this workspace right now with Kinfey. It's not on the exercise, but we are live and we are together. So I click on the little three buttons, dot buttons, and I click on Manage Access. And here I can add people and type Kinfey name. Yeah, and because Kinfey is a good colleague, let's give him admin rights. I trust him. It's added, so Kinfey can start working on this space with me, and we will create a notebook, and the notebook is collaborative. We can have a discussion there directly in the notebook, so we can do a pretty collaborative stuff within the workspace. Kinfey, I will be your hands, but can you guide us through the creating a notebook step?
Yes. Yes. The first thing, I finished some setting from Chris led me to join the notebook. And then you can open the notebook and finish open the notebook. Yeah, and the first thing is open the notebook. Yeah, and then you can follow the type something is follow the guideline. You can see the guideline there. I think Chris, please run right down the guideline. Yeah, down the guideline.
Yeah, we need to convert that to Markdown cell.
Markdown. Yeah, you can set the Markdown here and to just like copy. Yeah, just like copy here. And then finish the copy. Oh, you can see the notebook is marked down, and just like you use notebook in your local environment, and then you can add code. Yeah, here and then load the data into data frame. Sometimes you need to just copy these things. I think the load data you can see the load data is from a block storage. Yeah, and give the container name and some block storage account here. just like to let you to load the data in data frame to let you to know the data architecture so click run, just like this. You can see the run cell. Oh, okay. When it finish, you can see is the remote path is okay. Everything is okay. And then when you see this result, you can continue to add a new cell to continue to new cell. Yeah.
And just before we go to the new cell to actually display the data, for those of you who are already using a notebook, or maybe you're using Databricks or Spark already, I don't know if you saw that, but basically I created a notebook and I clicked run, and then in a few seconds it runs, and that's it. That's one of the magic tricks of Microsoft Fabric. Fabric is a SaaS product, a software as a service, like Microsoft Teams if you want. And when you want to chat with a colleague, you just go on Microsoft Teams, create a new conversation, and you start typing, and that's it. You do not have to provision any cluster, any server, and that's the exact same thing in Microsoft Fabric. We have things we call capacity, so you need to provision a Fabric capacity. But apart from that, you don't need to provision any cluster, set up anything. You just create a notebook, click on a cell, and you're automatically attached to a serverless Spark instance that is running somewhere in the Microsoft Fabric cloud. And you can start running your code without worrying about any detail about the infrastructure. That's one of the really cool things of Microsoft Fabric.
And then they display the data. Yeah.
So in a few seconds, you will have access to the data we'll be working on to actually train our machine learning model. This data is data about patients who have diabetes. And so we have a bunch of information there. We have their age, their sex, BMI stands for body mass index, BP stands for blood pressure, and it's actually you probably know that the blood pressure is actually two numbers. What they've done here is they computed the mean, the average of the diastolic and systolic blood pressures to get just one number. And then we have a series of columns, S1, S2, S3, S4, S5. And these columns actually correspond to different information from a blood tests, like the cholesterol serum, the blood sugar level, that kind of things you want to watch out if someone may have a diabetes. And the last column, which is really important because this is what we will train our machine learning model on, is the Y column. And the Y column here is basically quantitative measure of the disease progression 1 year after the baseline. So 1 year after the blood pressure test and the blood works, basically. And its number, it's not yes or no, it's not does the patient have diabetes or not, is actually numbers that go from one range to another. So when you get your data, it's important to understand the data you have because you will need to do something that we call the feature selection, which is basically try to understand which columns, which data you have may be relevant to train the model. In the exercise, we will train our model on all the columns, but in a real-life project, you will need to do a lot of work understanding the data and trying to understand which of these different features are the best fit for using into your model. Yes. And one of the interesting things of Microsoft Fabric here is you have a ton of different tools to actually explore data. So here I'm comparing number of people with an age based on sex. I can do other things. Let, for example, try to understand by age, what is the blood pressure and body mass index. Try to understand if there is a correlation between age and either of these two parameters. Blood pressure, yes, it seems that it's a kind of a triangle, and body mass index is a little bit more difficult to understand, but we'll see what we can do in the model. I talk about data preparation, data quality before the session, at the beginning of the session. One of the tools we have in Microsoft Fabric is the Data Wrangler tool. It's a no-code tool that allows you to basically get information about your data, get characteristic data shape, and automatically apply operation to clean up your data without having to write any code. This code will be written for you. And one of the announcements of Microsoft Fabric, if you already have looked at the Data Wrangler, is Data Wrangler is now working with Spark data frame and not only Pandas data frame. So here I can explore my data and I can do a bunch of operation to actually clean up my data. So we already have a data set that has been cleaned up, so nothing to do for us here. The last thing we need to do before jumping into actually training the model is we will be using scikit-learn, and scikit-learn requires a Pandas data frame and not a Spark data frame. So we need to do a little conversion before working on the training. I think, Kinfey, we are ready to start with the training. Do you want to explain us what we are doing in this first step with a lot of X and a lot of Ys, what this is all about?
Yeah, I think this step, we need to some training data and some test data separate. And when we finish this, we need to finish some trade step. The first step, just I say before, is use MLflow. You need to set the your experiment name. You can set a different name here because you have many experiments. And when you train, you can set different experiment. Just like here is experiment and the best, and then set the experiment. It's very important step. You need to let the flow to know. Oh, you are current here to finish some experiment name. So, Chris, please help me to copy to the cell.
Here we go.
Yeah. When you finish, the MLflow know how to use this. Then at the code, this is a step I love because in the past I need to write some algorithm to finish this, but MLflow just like some size kit to set more algorithm here. In this sample, we use linear regression here. You can import the line regression class and then to set the class regression to your training algorithm and train to get the matrix some estimator and line regression. You can see that in my Microsoft Fabric Global, it will give you some spend some time to training. Many people say, oh, training we can take a coffee or take a break to rate the result. Our data is very small, so this time finish. If we want to change some linear regression, you can change something here. You can choose different algorithm to finish. But I think this time the sample is the line regression and it's okay. You can see the MLflow set the log palm in the estimate and line regression. So this time you can see the result in the row cell. Chris, can you help me to change something just like linear regression and it's okay. Algorithm.
Yeah, we will jump to we will use the same system and actually train it same data and train them to a different algorithm and to compare them. But I just wanted to highlight where MLflow is playing something there because it's a bit of magic and we don't really understand what is happening and why it's so cool it happens. Basically, with that command with MLflow start run. We instruct MLflow that we are starting a new phase of training with a set of parameters and a specific machine learning model. And we use MLflow autolog. And because MLflow knows a lot of things about scikit-learn machine learning framework, it will automatically log a ton of different things. It will log the parameters, it will log the configuration of the model, which model has been used, and it will also log some performance metric about the model. We will see them in just a minute. And you can actually have a bunch of different methods on the MLflow object. Let's see if I have them. You can log artifacts. So it's already done for you by autolog. So actually the model has been serialized and saved into MLflow, so we don't have to do it. But sometimes you want to log anything, so you can log artifacts. You can log some metrics if you want to compare a specific metric that is not already logged by MLflow, or just log some text, log anything. So that's a bit of magic, and we will see how this magic plays in a second. But you're right, Kinfey. Let's continue the module and actually do the exact same thing, but with a different machine learning algorithm. Basically, the linear regression is a very simple machine learning model, but depending on your data set, it may not be fit. Decision tree is a little bit more complex. It can detect and so predict a more nuanced thing based on a tree of decisions, hence the name. So that's it. I've now trained 2 machine learning models, and we'll be able to use MLflow to share to compare these two different runs, these 2 different training sessions. So let's go ahead and create a new cell. And what we will do here is we will use the MLflow library to actually search for all the experiments I have in my workspace. So I only have one, the experiment diabetes. That's the one, if you remember correctly. That's the one we've created here. We created a new experiment, set a name, and now it's on the MLflow library, and I can retrieve it with the MLflow search experiments. So let's continue, and you can do a little bit. You can add parameters to the search experiment or get an experiment by name if you already know the name, which is the case here. And an experiment is basically could be kind of a project. So you know you will be training a machine learning model several times with different parameters or different machine learning models, algorithms. So the experiment is, okay, I have this problem, and here is all my different attempts to find the perfect model. And each attempt is called a run in the MLflow lingo. So we can search for runs with, again, MLflow search run method. And here I'm ordering them by start time. So I have the last one in the first position, and I just want the last two runs. And I have a bunch of parameters here, like the run name, which estimator I've used, so which machine learning algorithm I've used, who has launched this training. It's me in this case, and a ton of other information. And right from here, right from the notebook, you can do interesting things like using the matplotlib library, which is a well-known library in Python to produce graphs, and basically get all the different runs and plot a graph about the performance of the model. Here we are using the R-squared metrics to compare the performance of our model. I will not go into details about R-square and other metrics to evaluate the performance of your machine learning model. For this example, just consider that the R-square score is between 0 and 1, and the closer to 1 you are, in very simple terms, the better you are. It's not always true, but I will not go into that detail. So here we have our two trained models, the linear regression and the decision tree, and it seems that the decision tree is performing better than the linear regression. So that's cool. We've done 2 runs, and we know now which one we will need to deploy. Everything we've done here, we've done it by code, but because MLflow is tightly integrated into Microsoft Fabric, you can also use the UI to do most of these things. Let me go back to my workspace, and now you see that the experiment has showed up, and I can click on that experiment, and I can explore all my different experiments. So I can see my 2 different runs. The first one here by name, and you can see the parameters where I logged the estimator, linear regression. So loyal shoe is a linear regression, and honest color is my decision tree. I just show you how to use matplotlib to compare the performance of 2 models. Well, you can do it here. If you go on view and click on run lists, you can actually choose 2 or more runs, and you have some performance metrics that is showing up here as well. So we can also compare them. And here we are with our training R2 score. And what is asked into the model is to change a little bit this by this, I think. So you can basically get the same diagrams, the same graphics that the one we've generated with matplotlib, and this is the same data. So honest color, which is our decision tree regressor, is performing better. Last step is when you have picked the best model is to actually publish it, so you can use it through Microsoft Fabric. And this is very simple to do. You just have to select the model and click here on Save as ML Model. And then you can either create a new model. That's what we will do here. You will need to select a folder. I will go back to this in a minute. And you need to type a name. In this case, let's go with diabetes model. I click Save. It will be published into the model registry, MLflow model registry that is integrated with Microsoft Fabric, and this is hosted by Microsoft Fabric. And I can go to my ML model. I will go to there in a minute. But I just wanted to give you a glimpse of what's inside that registry. It's this. Here you have the ML model, which is a very important file in the MLflow world because it describes the model. That's one of the powerful concepts of MLflow. And the model.pkl is actually the model that has been serialized and that could be used later on. Someone asked in the chat, I've completed the task and built an ML model, but I'm unable to apply it on a new set of data. How do you apply a model on a new data set? So let me show you how to actually do it. I will go back to my workspace, and now you can see that I have a new diabetes ML model that has been published. So I can click here and just go there, apply this version, and I can do it with a wizard, a UI, or just copy the code to apply it. So I can go there, copy the code, just replace a few things like my input table file path, my input columns, that kind of things. The model version, one of the cool things, and you can see it there, is under a model, you can publish revisions. So you can publish a first version of the model and go back to find the data, clean the data, prepare the data, train a new version of the model, etc., and republish it as a new version. That's one of the features of MLflow in Microsoft Fabric. And now, why it's not working today when you are doing exactly these steps? It's because if we deep dive a little bit more in the ML model file, you will see one of the cool things of MLflow is it's store a signature of the model. So what is the input of the model and all the different data types, and what is the output? And here, if you are just training them using the content from this learn module, you will end up with a tensor type of input and tensor type of outputs. And to use a tensor type into Microsoft Fabric, you need to do a little bit of conversion as well, but it's not done by default. So that's why you're having an issue. But let me share with you a link to another lab where you have the solution. Generate batch predictions. Yes, and let me share it to the answer to your comments. And basically what we are doing differently here is, let me open up another version of this, is this. There's a little bit of magic to make a model works better by default with Microsoft Fabric and with Spark data frames. Is yes, train here. It's here. Yes, it's here. Here you can see that we have the same code that we had before, like MLflow autolog, decision tree regressor, and calling the fit model to do the training. But what we are doing one more thing. We are defining a schema. So we are explicitly saying what are the different columns we want as an input and what is the different type we want as an output of the model. We create what we call a model signature, and we log the model manually instead of doing it automatically. And when you do this, let me switch to my workspace. I think it's here. And if we go back to the ML model definition, here you can see on the signature that we have the different columns that are very well explicit. You don't have a tensor now, which is basically a vector or list of items. You have an exact signature, and when you're doing this, you can use the wizard and go from a lakehouse table directly into your model and making some predictions. Kinfey, do you want to add anything up before we wrap up this exercise?
Yes, I think on this is very interesting. Chris, many people to maybe ask, can we get the model? Yeah, can we change the ONNIS model? Because ONNIS is very popular machine learning model format to some device to you can deploy ONNIS model to IoT device and some backend and can support this in Microsoft Fabric.
Yes, that's a good question. If we go back here, on the model I've already trained using this workshop, you can see that I'm using what we call the pickled model, and the serialization format of the model is pickle. Pickle is a Python library that basically takes an in-memory Python object and serializes it to disk. It's great for a lot of different models, but especially if you're doing deep neural networks, the pickle format is not the best for serializing things. And the other issue is pickle is a Python thing. Is not something you use on a different set of languages, for example. Yes, you can absolutely change things. And actually, I have almost the code ready. If I go back to my workspace and to the notebook I just showed you before, you can see here I'm calling the MLflow autolog methods, but I'm saying to MLflow, hey, do not log the models. Please log the parameters. Please log all the metrics about the performance of my model, but do not log my model. And what I'm doing is I'm calling the MLflow log model method to say to MLflow, hey, please, this is a signature, please log that model. And here you can add a bunch of code before to transform your model into an ONNX model and actually log the ONNX version of your model and then use the ONNX version of your model.
Okay. Another demo is in how to train the model, but I want to deploy the model to conception the model. How to do this? Yeah.
I didn't saw the question. The question is, can you import a train model in Fabric to Azure ML?
Yes.
Yes, you can do it. You can do it in a different ways. First, you can definitely call Azure Machine Learning APIs from the notebooks. And so you can do the training there using the Spark and then pushing the model to Azure ML. You can also download with the MLflow, because MLflow is also supported in Azure AI, Azure ML, sorry. So you can use MLflow to download the artifacts from the Microsoft Fabric MLflow registry and push them to the Azure ML registry. So that's another way of doing it. But if you plan just to use this machine learning model within Fabric, you can just stay the models into a Fabric workspace and that's it.
Okay.
Cool. Chris. I think it's time for our knowledge check. We will see if everyone has followed along with us. So we will start by the first question, and you can answer the question live. So please take a moment to open up a browser or use your cell phone and snap that QR code and to go to aka.ms/polls-e. We will publish the poll anytime. We have a wonderful producer in Backstage that is publishing it. It's published. So let's go review that first question. So you have prepared the dataset that you loaded into a notebook. You want to train a classification model. What you should do before training the model. You have three possible answers. A, split the data. B, score the model. Or C, evaluate the model. And I will give you a few moments to launch the pool and start answering the question. And I see a few of you have already answered the question. So far, so good, it seems. And to give you a bit of hint, Kinfey described, I asked Kinfey to describe the cell containing the code but is actually doing what we need in that question. So we will give you a little bit more time to actually answer the question. So far, we are having one question with a lot of answers. One answer with a lot of answers. But people have been voting on the other two ones as well. So we'll see. Okay, give you 20 seconds to complete the vote, and then we will reveal the solution.
I think this is very easy.
Yeah, the first one. It's the first one. It should be easy. So let's reveal the question. First part of if you think about the data science process, first part, what is the question you're trying to answer? Second point, you're getting the data. Third point, you're preparing the data, cleaning it up, etc. And then just before actually training the model, which is calling the fit method on your algorithm, you need to split the data.
Yeah.
You need to split the data between a trained data set and a test data set. And you have everything into scikit-learn to do it for you automatically. But that's the first bit. Bravo, I would say, to most of our attendees that answers this question correctly. So let's go to the second question now. Which feature in Microsoft Fabric allows you to write and run code to train models? And you have three answers. Answer A, notebook. Answer B, experiments. And answer C, models. That one should be pretty easy as well. We spend most of the time in one of these three type of items. So it should be easy for you to vote on that questions. And you're voting. Let's give you 15 seconds more to cast your vote. And again, we have 83% of you that are selecting the right answer. So I think we can go to the reveal because most of you have the right answer already. And the answer B is notebooks. Experiments is just a library of your current experiments. Think of it as a basket in your desk. You're having some drafts of models, you're trying things, etc., and you put everything on a basket on your desktop. And when you're happy with one of your models, you publish it. You move that piece of paper, you move that model from the experiments to the models, to the bookshelf, to the library. So where you write code is into your notebook. Last question for a little bit more difficult for this knowledge check. You want to log the accuracy of a model. Which logging function should you use? It's actually not a function we've used, to give you a hint. So you have three choices. Answer A, MLflow log param. Answer B, MLflow log metric. And answer C, MLflow log artifact. We used one of them. We didn't use the two other ones, but think of accuracy as a way to understand if your model is right or not. So it's with this, it's probably easy to understand which one. What are the things we've been looking for at the experiment screen? We've seen diagrams, etc. And when we were doing this, we were talking about 80% of you have the correct answer already. Kinfey, do you want to reveal the last good answer?
Yes. You need to no B. You select, you give the answer to, but I need to tell you, you want to get the accuracy of model, you need to use the log matrix. This is the this is the good things to get the result. Okay. summary. Yeah, Chris, continue. Yeah.
Yeah, so thank you for being with us. You were a few hundreds with us today, so I'm very happy to be still up at 2 a.m. Because we had a wide audience and a great question in the chat. What we saw today is the basics of training machine learning models with open source frameworks. Then we see how you can train models with Notebook in Microsoft Fabric, and obviously how you can track model training metrics with MLflow and experiments in Microsoft Fabric. If you want to learn more about Microsoft Fabric, you can watch more Fabric notes, little drawings with concepts about Microsoft Fabric at aka.ms/fabric notes. You can still complete the exercise. The Learn module is up there online for your own consumption at your own pace. And don't miss, we have other Learn Live series at Microsoft Ignite. So do not hesitate to join another session. I hope you're enjoying Microsoft Ignite so far, and we wish you all a great rest of Microsoft Ignite. Bye-bye. Bye, Kinfey.
Bye. See you next time.
See you.